Hey folks, thanks for joining our third live webinar. My name is Lucas Demarchi. I'm with Full Gauge Controls, live from Miami. Today, we're going to be talking about principles of defrost in commercial refrigeration. This live webinar is brought to you by Full Gauge Controls and Robert Shaw. Robert Shaw is the official distributor of Full Gauge Controls in USA. You can find Full Gauge products as well as Robert Shaw products in most wholesalers across the country. So, a couple of things I wanted to share with you. First, today we're going to be talking about defrost cycle, and we do have a guest that will join our call. As we have on the other live events, we're going to have a live guest that will join our call after the presentation. And for those of you who like the content, please leave a like on our page, subscribe to our YouTube channel, follow our social media, stay tuned with our materials, support materials, new product launches, and more. One more thing, another thing I wanted to ask you, if you could leave a comment saying what would be the time that would best suit you for a live event. What's your preferred time to watch those live webinars? If you can leave a comment in here, that will help us to guide our future actions. So let's get started. So our presentation today will cover principles of defrost, including how to prevent frost buildup, what are the defrost methods available, how to determine the most efficient defrost cycles, and how to optimize your defrost cycles. Refrigeration equipment is responsible for over 25% of the total energy consumption in a restaurant. When we look at supermarkets, that ratio increased to almost 50%. Refrigeration systems are responsible for up to 50% of the total energy consumption in supermarkets. When we look at defrost cycles can actually represent up to 15% of the total consumption of your refrigeration equipment. And not only for the heat that is not only for the resistance that is activated to defrost the ice, but also during the ice formation process, which the evaporator coil loses efficiency. So there you have energy wasting, because your coil is actually forming ice, and that ice is preventing heat transfer. So there you have an energy consumption. In addition to that, once the electric heaters are on, there is drawing a lot of electricity. In addition to that, that heat that is created with the coil, some of that heat get transferred to the room, to the refrigerated space, and eventually you're gonna have to remove that heat from the refrigeration space. So there is another energy spending right there. So to sum that up, that's the importance of having a precise and efficient defrost cycle to optimize your energy consumption and increase the life cycle of your equipment. So here we have a few tips on how to prevent frost buildup. So a few ways that you can actually, so first of all, frost. Frost is frozen water vapor. Ice forms when frost melts into water and the water freezes. The colder the evaporator, the more water vapor will freeze out of the air. So the idea is to try to maintain a low, the idea is actually trying to maintain a minimum temperature difference between the evaporator and the room. So that way, you're actually maintaining. So how do you achieve a low TD, the temperature difference between room and coil? So a low TD is normally between 8 and 10 degrees Fahrenheit. And there are a few conditions that can help to achieve such a low temperature difference. Some of those conditions are a large evaporator surface. A fully active evaporator will also help to maintain a low temperature difference. Rapid and fast air circulation, and a frost-free surface. These conditions will promote slow frost buildup, high suction pressure, high capacity, and efficiency. Another good alternative to reduce frost buildup is the adoption of door switches. By connecting a door switch to normally digital controllers, some of the digital controllers will feature a digital input, which will allow the connection of a door switch. And based on that door switch, you can monitor when the door is open, closed, and have alerts when the door is left open or when it has been open for a longer period of time. Another good alternative to reduce ice buildup is to stock correctly. Normally, you have to leave 30% of the refrigeration space unoccupied, free. So that way you allow air circulation throughout your walk-in cooler and freezer. So by stocking correctly, you allow better air circulation and you will reduce the frost buildup. Another nice tip for reducing frost buildup is to avoid storing hot items. So for instance, in restaurants, when you have a hot pan coming out of the kitchen, especially on freezer applications in low temp walk-in boxes, ideally, you would take that hot pan and leave in a refrigerated space, let it cool down before it entering the frozen space, your low temp device. So that's another good alternative to reduce ice buildup. And the organization of the refrigeration space, which will provide less time of open door. So those are just few tips that can help to minimize ice formation. Now we're going to take a look at what are the defrost methods available. We're going to start from the off-cycle defrost, which is also known as a natural defrost or air defrost. This is commonly found on medium temp refrigerated units, applications that have room temperature from 36 and above. The natural defrost cycle is the most simple defrost cycle available. That basically works stopping the refrigeration system for a certain amount of time, letting the evaporator coil naturally melt down the ice. So you're gonna run the refrigeration, the cooling process on and off for 4, 6, 8 hours, and you're gonna stop that system for a set amount of time, 10, 20, 15, 20, 30 minutes in order to naturally melt down that ice present on the evaporator coil. So the off-cycle defrost is commonly found in medium temp applications. Besides the off-cycle defrost, another very common defrost method is the electric defrost. Electric defrost is commonly found in low temp applications, freezer applications. The electric defrost consists of electric heater, a resistance within or around the evaporator coil. During that process, the evaporator fans will remain off, preventing that heat to be transferred to the refrigerated space. After that defrost cycle, you normally will have a dripping cycle, which will allow the coil to drain all the water that was left from the defrost cycle. That way, you will prevent another ice. You will actually delay the ice formation. So that dripping process is important to delay the ice formation on the next cycle. But with the electric defrost, you're likely to have a high heat load transfer to the room because the coil heats up. And one important feature to use when you have electric defrost is the fan delay. You're likely to delay the fan after the defrost cycle. So what do you want to do? You want to cool that coil before you start the fan. That way you reduce that heat transfer, that heat to be transferred to the refrigeration space. So that's the idea about the fan delay. This is a very common, very easy to set up defrost, and very easy to maintain as well. This is one of the most popular defrost methods available, the electric defrost. Another defrost method presented in presenting low temp applications such as freezers is the hot gas defrost. The hot gas defrost actually use the heat provided by the refrigeration system to melt the evaporator coil. So that in this case, you don't have any heaters, you don't have any electric resistance to provide that heat. That heat is actually provided by the refrigeration system. So in this case, your compressor will remain on during defrost. This is actually the most efficient and quick defrost method available. When we compare a hot gas to a normal electric defrost, a normal electric defrost might take place during 10, 15, up to 20 minutes. While on the hot gas defrost, the cycle will be virtually 2 to 3 minutes. So as you can see, it's way more quickly, therefore will be way more efficient. And for the hot gas defrost, there are a variety of system design to achieve the same result. So one of the most common hot gas defrost design is the reversing cycle, where you have a four-way valve that change the flow cycle of the system. So the compressor will send the air, the refrigerant to the evaporator and will circle back through the condenser back to the compressor. In addition to that, there are other designs available. Three-way piping is one. There is one with a recirculation, a re-evaporator fan that will supplement evaporation to the cycle. So there are a number of designs that will be determined by the system manufacturer for the hot gas defrost. How to determine defrost cycles? So first defrost cycle we're going to be taking a look is the manual defrost. Manual defrost, it's a forced defrost. When you adopt digital controllers, most of digital controllers will provide you the option of forcing a manual defrost. With the full gauge controller, you can easily force a manual defrost by pressing the upper key for 4 seconds. Pressing the upper key for 4 seconds will take you to the defrost. It will allow you to activate and deactivate defrost. So the manual defrost is the first defrost we would like to share with you. Another very common defrost cycle is the time-initiated, time-terminated defrost. So guys, if you have any questions, please send all your questions in here. I have a mediator working with me tonight, Rafael, and he's helping to answer all your questions. And I'll be also taking a look at the questions, and hopefully we can bring some of these questions up to the screen and share with everyone for discussion. So please send out all your questions and comments throughout this presentation. So another very common way to determine defrost cycle is the time-initiated, time-terminated defrost. This is quite common in medium temp applications where air defrost is used. So basically that's what we were talking about on the air defrost, off-cycle defrost, where you have your cooling cycle for a certain amount of time, 4, 6, 8 hours, and then you stop that cooling cycle for 20, 30, 40 minutes for a set time that will allow a naturally defrost cycle. So this time-initiated, time-terminated is less efficient when you look at freezer applications, when you have another defrost element on the system. For example, on electric defrost, you don't want your heaters to be running for 20 minutes if that 20 minutes is unnecessary. You want to cut that defrost cycle when the coil has reached a certain temperature. So the time initiated, time terminated, that's the same concept of the mechanical timers. So basically, this is a concept that it's widely used in medium temp applications. When we move to the low temp freezer applications, we're gonna have a different defrost determination. Basically, commonly, our defrost will be time initiated, temperature terminated. So in this case, we're gonna be using a sensor, a temperature sensor in the evaporator. And that temperature sensor will determine the end of defrost cycle. Again, this is very common with medium temp as well as low temp application, but mostly in low temp freezer application. So your defrost cycle actually initiates based on a time. So 4, 6, 8 hours, whatever you set on your cooling time, that's going to be your defrost frequency. And the temperature terminated will always try to terminate the defrost based on the coil temperature, which is set at the temperature at the evaporator to determine the end of defrost. So, but in addition to that, you have a safety option, which is a maximum defrost time. This provides the option of terminating the defrost even if the temperature to terminate defrost is not reached. So for instance, if the sensor is not well positioned, if it is placed in a incorrect position, if the sensor is miswired, if you have any problem, you don't want your defrost cycle to continue forever. So you have a maximum defrost duration for safety reason. This is a fairly simple defrost determination method. You only need 3 parameters to set this defrost. You basically need to set your cooling time, which will be your defrost frequency. Then you're gonna set your temperature to terminate that defrost cycle. And if the temperature cannot be reached, you're gonna have a maximum defrost duration for safety reasons. So with only these 3 parameters, you can actually set an optimum defrost cycle. Another common defrost determination method is the real-time clock defrost. Real-time clock defrost is commonly found in supermarket case. The real-time clock defrost allows you, when you have multiple pieces of equipment in one installation, you want each equipment to enter defrost in a specific time, preventing inrush current, preventing the current peak when you have all your equipment entering defrost at the same time. So by setting the real-time defrost clock, you can actually reduce in-rush current as well as prevent defrost during the peak hours. For example, there is a restaurant which opens for breakfast and lunch. You don't want your defrost cycles to take place 8 o'clock in the morning where the restaurant is busy serving breakfast. Neither you don't want the defrost taking place during the lunchtime when the restaurant is busy serving lunch. And when the restaurant is busy, we know there is a lot of door opening, closing, people grabbing stuff out of the refrigerated space, putting warm stuff into the refrigerated space. So having defrost cycles during these busy hours is actually critical because your refrigerated temperature might increase. So that's the nice feature about setting a real-time clock defrost, is to allow each piece of equipment to enter defrost at a certain time. Another nice feature about the real-time clock defrost is the possibility to set weekly and weekend defrost cycles. For example, a warehouse, a refrigerated warehouse that does not work on the weekends, you might be able, since it does not work on the weekends, you won't have door opening and closing. So that is likely that you can reduce your defrost cycles from 6 to 4 defrosts a day, for example. So the real-time clock defrost provides you such flexibility to adapt the defrost to when is the most convenient time for it. Another defrost determination that is becoming quite common is the temperature-initiated, temperature-terminated defrost. This is also known as on-demand defrost or adaptive defrost cycle. I'm sure you have heard those expressions, on-demand, adaptive defrost. And what that means that your defrost cycles will be performed only when it's needed. So instead of starting the defrost on a cyclical time base, for example, one defrost every 4, 6, 8 hours, you don't know if your system is calling for defrost if the defrost is actually needed during those times. You normally start the defrost when your coil loses efficient below 90%. That's when you normally start your defrost cycle. So by performing the on-demand adaptive defrost, you're likely to reduce the number of the daily defrosts quite significantly, because there are a few ways to do that. One way to do that is by monitoring the coil temperature and adding some validation times to prevent false defrost calls. Another way of doing it is to monitor the temperature difference between room and the coil. And when there is an increase on the temperature difference, means that the system is losing efficiency, therefore a defrost cycle is required. So what I mean with it, there are different algorithms that allows the same purpose, that delivers the same benefit. We do, as far as full gauge, we do have different ways of performing the same objective. So some of our controllers are loaded with the capability of starting the defrost based on the coil temperature with validation times to prevent false defrost calls. Other controllers will have the temperature difference as an algorithm to perform that on-demand adaptive defrost cycle. But what we brought today was an example of, with only 5 parameters, you can actually set this adaptive defrost cycle just by setting your coil temperature to start the defrost and how long that temperature has to remain in place to actually enter the defrost cycle. That way, you're actually preventing false defrost calls during that event. Is there any questions in here that we can address about this adaptive on-demand defrost Any of you guys are currently making use of this feature and would like to share your view, your perspective with us, please feel free to do through the comments in here. So defrost optimization. We have a few ways. Here are some tips to how to optimize the defrost cycle. One very easy way to reduce defrost cycles is the adoption of economy set point. Economy set point will actually allow reduced running of compressor. For example, you have your normal operating set point. Let's say we set our normal operating set point. Remember, the set point is the cutout temperature. Is the temperature that the system will be deactivated. So let's say we have that normal operating set point at 20 degrees Fahrenheit. During night times, when I don't have any door opening, closing, I don't have any traffic within the store, I can actually up that set point to 25 degrees. And that 5 degrees difference on the cutout will actually reduce my compressor cycles and will also reduce my defrost cycle, my defrost necessity. Since I will have less compressor running hours, I will likely to have less defrost cycles. Another nice way to optimize the defrost cycles is the adoption of a door switch through the digital input of those electronic controllers. By adding a door switch to the digital input, you can actually monitor the door opening and shut down the evap fan when the door is open, for example. So if the door is left open, you might want to deactivate the evap fan, preventing that hot air to create that that hot air becomes the frost, which becomes the ice. So you're actually, by shutting down the fan, by adding the door switch, you have possibilities to monitor your evap fan based on it, which will improve efficiency as well as reduce your defrost cycles. Another nice option to optimize defrost cycle is by controlling your evaporator fan. And to control the evaporator fan, you need a dedicated fan relay output. But with that fan relay output, you can actually cycle the fan while compressor is on and off, using that thermal mass in the coil and transferring that mass to the room, as well as providing a uniform temperature within the room. So by cycling the compressor on the fan, by cycling the fan on and off during compressor off cycle, you're providing a uniform temperature within the refrigerated space, as well as using the energy that is left on your evaporator coil during the off cycles and transferring that energy to the room. And another nice way to optimize defrost cycles is with remote monitoring and control. By having predictive reports, by having the remote monitoring capability, you're actually able to better understand all your system variables and easily identify potential inefficiencies, raising possibilities of predictive actions, such as adjusting your defrost cycles, adjusting your defrost cutout temperature, adjusting different parameters for enhancing the system performance. So those are some of the tips we have to how to optimize your defrost cycles. Oh, one thing that we would like to share with you is the programming key. All our controllers are actually compatible with the EasyProg, which is a programming key. This is actually nice when the adoption of the EasyProg is actually a very nice feature, a very nice tool when you're using the real-time clock defrost. EasyProg actually allows you to host up to 9 independent setting options. By having these 9 independent setting options, you can actually have one defrost recipe for your weekdays. You can have one defrost recipe. You can have one recipe for your electric defrost. You can have one recipe for when you have the hot gas defrost. You can upload one recipe for real-time clock defrost, for adaptive on-demand defrost. So all these nice features can be preloaded to your EasyProg for a easy programming, easy and quick programming. And another thing that I would like to share with you is the FG Finder app. There you will find all the product manuals, installation videos, and where to buy locations. So if you download the app, make sure you activate the notifications, because the notifications we actually use to promote all these training opportunities, product launches, and other news that we are always releasing. So those are the apps that I would definitely recommend you to download. That's what we had today about the defrost cycle. I do have a guest that is trying to join the presentation. However, we are having some looks like we're having some technical problems with his connection. Let us try, we'll keep trying to connect. Person that will join our live webinar today is an experienced mechanic engineer, an experienced contractor that has done several installations using these different defrost technologies, from electric to hot gas defrost. So I'm hoping that he can join our live event today and share some of his experience with us. In the meanwhile, is there any questions that we could be answering today? Who of you have ever worked on a hot gas defrost system, for example? What are the challenges you face when you're working on a hot gas defrost system? If you can please share on your comments, and I will be happy to share with everyone in here. Well, folks, looks like our guest is having some serious technical problems, and it's not able to join our live today. So I'll make sure I'll bring him to another live event. What we are doing, we are actually performing a series of live training events during these social distancing times. So every Wednesday, we have a live event in English for our English-speaking audience. Yesterday, we had a very nice training for the Spanish-speaking audience. So every Tuesday, you will have training content for Spanish-speaking audience. Wednesday, we have our technical content or presentations for English-speaking audience. And Thursday, we have the Portuguese trainings. So for our audience in Brazil, Portugal, and other Portuguese-speaking countries. So here we have a question that do you have digital controllers that work with ICE machines? Yes, Michael Brennan, thanks for your question. And we do have, in fact, we are actually working with some ICE machine manufacturers which have adopted full gauge controller as their solution, their temperature control solution for their equipment. So we do have, we have from a very simple MT512, which provides one output and one sensor with off-cycle defrost. We also have TC900, MT444, and other controllers that can definitely be used for ice machine applications. So yes, we do have. Here we have another question. Edson Guimarães is actually sharing with us that he's using hot defrost on freezer tunnels. That's a very interesting application. That's a very interesting. And how are you controlling your defrost cycle? Is it time initiated, temperature terminated? How are you controlling that process? If you can please share with us. Marciano, are there control box available? Yes, we do have mounting enclosures. In fact, we have a very nice plastic mounting enclosure that goes in line with the National Electric Code in the US and allows you to mount our full gauge controllers in a DIN rail type of surface. So we do have, and not only the enclosures, not only the boxes, but we also have other mounting accessories, such as mounting plates and other installation accessories. Here's his. So Marciano is actually complementing his question. If we had a box to house the controller, and he's asking the box. So I understand, Marciano, that you're asking about an electric control panel, like a control panel electric box. No, we do not manufacture those electric control panels. Actually, our customers are the ones who manufacture those panels. We sell our temperature controllers to electric panel manufacturers who assemble those electric control panels. And then they will include contactors, they might include circuit breakers, thermal relays, and other protection device. So we actually supply controllers to control panel manufacturers who make the final product. So Yasser is asking, is FG planning on introducing a wall mount controller? Well, we do have some wall mounting controller, but for solar heating applications. If you look at our line of solar heating controllers, they're mostly wall mounted. For refrigeration applications, as far as I know, we don't have any existing project for a wall mounting controller. However, the adoption of our enclosures or the enclosure part number is GB01. So if you go on fullgauge.com, you can actually find the specs of our enclosure, and that will allow you to mount a controller in a wall. Here we have a question from Kurt Fisher. Thanks, Kurt. Thanks for joining our live, and thanks for being here. So, are your products UL listed for use in Canada? Yes, our products are listed, UL listed for Canada, US. We also have NSF, and our controllers are also approved for hot gas defrost. So, looks like our guest has just joined in here. Ed Carroll. Ed, please, if you can join the live through the link I sent to you via email. That's the one that's the link will allow me to add you to this live presentation. So if you can please just click on the link I sent to you, and I'll be able to add you to the presentation. But thanks for being here. Thanks for your support. Here we have a very nice question from Michael Brandon. Hey, Michael, thank you. Thanks for being here. Thanks for joining our third live webinar this week, talking about defrost, principles of defrost. Our first webinar 2 weeks ago, we talked about a medium temp controllers for cooler applications. Last week, we talked about freezer controllers, low temp digital controllers. And this week, we were talking about defrost cycles. So Michael is asking if the products can be retrofitted to upgrade existing system from mechanical timer to digital. Yes. In fact, our digital controllers, for example, the TC900 will actually allow you to replace the thermostat, defrost timer, fan termination switch, and the defrost termination switch. So you're actually in addition to the thermometer, because the digital controller will provide you a nice big digital readout. So with our controllers, you're actually able to replace 5 mechanical components with only 1 temperature controller. So the answer is yes, it is good for retrofit. And in fact, we have videos available that demonstrate how you can use our controllers as a retrofit of old mechanical systems. So Eddie, let me know if you're going to be able to join. If you can, just click on the link I sent to you, and I'm going to be able to merge you into this live. Any other question, guys? Anything you would like to revisit during our presentation? Is there anyone making use of the on-demand adaptive defrost technology? Anyone that is using the temperature initiating, temperature terminating defrost? This is a feature that is becoming quietly useful for a number of applications, in fact, but walk-in applications are normally making use of such feature, because we actually study this defrost method, and we have identified that we can actually reduce up to 90% of defrost cycles with the on-demand defrost. So that provides you a more efficient and more optimum defrost cycle. Really good question, Michael. What kind of efficiency do you see retrofit from mechanical control trying to figure out on return of investment? That's a really good question. To answer this question, I would like to go back to the presentation and bring one slide that will definitely put some light into this topic. So just going to bring one slide and we can look at this. Okay. Here was the question from Michael. What kind of efficiency do you see retrofit from mechanical control to digital? So this is a study provided by Energy Star. So if you go on energystar.gov, you're able to download those studies about energy consumption in supermarket, restaurants, and other retail space. So refrigeration equipment is responsible for actually over 25% electricity consumption in restaurants. When we look at supermarket, that ratio goes up to 50%. So 50% of the total energy consumption in a supermarket comes from the refrigeration system. The adoption of digital controls will provide you a more precise control, allowing to reduce running time and improve. For example, when we look at the defrost cycle on the time defrost, when you have a time-initiated, time-terminated defrost, or a time-initiated, temperature-terminated, you're running defrost every 4, 6, 8 hours, but you don't know if the defrost is actually needed during that frequency. What we have done, we have actually studied the on-demand adaptive defrost technology in an application where we actually optimize 90% of the defrost cycles. So the adoption of those energy efficient solutions will allow you to reduce about 20% of energy consumption. So, and there is no much incremental cost. When you look at the number of components that these replace, there is virtually no incremental cost switching from the mechanical over to the electronic solution. So the selling point in here is, first, you're going to have a better temperature control product. Your products will be kept within a better temperature ratings. So food safety is the first selling point, Michael, that you can bring to your customer. Food safety. In addition to that, energy savings. You can save up to 20% energy just by switching from a mechanical thermostat with a time defrost to an electronic controller that will control that process based on a microprocessor and have energy efficient defrost within it. So Kurt is bringing another question in here. Do you have a defrost controller for multiple cases? If so, can your controller be set up to do on-demand defrost for those cases? So Kurt, let me see if I understand you correctly. So you have a rack system with one condensing unit supplying refrigeration to 2 or 3 cases. And you want those defrosts to be interconnected. Is that what we are talking about in here? If so, there is a way to synchronize the defrost with our TC900E log controller. It's actually, you will synchronize that using the digital input feature of those controllers. So yes, there is a way we can actually guide you through how to achieve that with our TC900E log controllers. And in fact, our TC900E log comes with a free software, which is the CTROD software that allows local and remote monitoring and control. So here is a comment from Edson. Thanks, Edson. Thanks for your support. Thanks for relying on Full Gauge and on CTROD software for your refrigeration and heating applications. And in fact, this CTROD software also helps to comply with FDA requirements. So if you're working on application that have the on projects that must comply with the FDA requirements, CTROD is a solution that can provide you that compliance, that can help during compliance. So this is something that I would like to point out as well. Well, guys, looks like our guest is having technical problems and will not be able to join this call, this live today. But I'll make sure he's joining us sometime, maybe next week or after that. and hopefully we can connect with him later, because I'm sure he's gonna have a very valuable inputs to our presentation. Here a question that Michael Brandon is asking: do your controller work with any brand sensor? That's a good question, Michael. Every controller manufacturer have their own sensor. Basically, those temperature sensor, it works. There is a temperature and resistance chart. So, in order, the sensor reads a certain temperature when it is at a certain resistance ohms. So most controller manufacturers use 10,000 ohms at 25 degrees Celsius. That's what we have for our temperature sensors. Our temperature sensors are 10K at 25 degrees. However, outside the 25 degrees range, you might have a temperature difference because the curve is not the same for every control manufacturer. But our controllers provide you the offset option, which allows you to adjust any temperature deviation that might have been created by a different sensor. Or another alternative you have is just strip the tip of the sensor and connect our tip. If you don't want to rerun the sensor on the equipment, you can just cut the tip out and put our full gauge tip in, the sensor tip, wire that back in, and you're going to be using our sensor in that case. But anyway, if you do connect a different sensor manufacturer in our controller, it will work. However, you might have some temperature difference in the range. So the recommendation in that case is make use of the offset the offset function to calibrate that deviation which might be created for changing the sensor. Here's a question from Jaime Barrera. In percentage, how much more refrigerant gas do you have to consider to use defrost for hot gas? It's a very good question, Jaime. However, this will depend on what design have you used to the hot gas system. Different manufacturers have different designs. So during this presentation today, we brought a design that is commonly known as a reversing cycle device, which makes use of a four-way valve. There are other type of hot gas design systems. You have a design that use the normal flow cycle for the refrigerant, and you have a re-evaporator fan after the evaporator. So there are different design cycles, and based on each design, you will have a specific charge. So I would not be able to answer you exactly in percentage how much more refrigerant you would need, because that will depend on the design of that hot gas defrost system, also on the piping line, how long is the piping line and all that. So unfortunately, I would not be able to bring any statistic data in here. Well, I'd like to thank you very much for joining our third live webinar. So it was a pleasure to have you all in here. As I mentioned before, next week we're gonna have next week we're gonna have another live webinar in English on Wednesday. If you're connecting from Latin America, every Tuesday we're gonna have a live Spanish speaking webinar. And if you're connecting from Brazil, Thursday we have the Portuguese speaking webinar. Just to finalize, Michael Brennan is asking, how long are the warranties? Warranty is 2 years, Michael. Our controllers feature 2 years warranty. And also outside of the US, are we in Cayman? Does warranty change? No, warranty does not change in the Cayman Island. You have 2 years warranty wherever you are. So our warranty is actually firm at 2 years. So again, thank you all very much for joining our live webinar, and I hope to see you back next week. And if you like the content we had today, please leave a like on the video and subscribe to our channel. We look forward to see you next week live at our Full Gauge YouTube channel.